Hello everyone and welcome to Science with Elliot, and this is a special episode because after my short Christmas hiatus, what a merry hiatus it was, I'm here with, in with a bang, my second Q&A, this time with not 15 but 20 questions once again. And this time, it's really time to go now. So one is, how many years does it take for the Earth to orbit or go around the Sun? The weird thing is, it's exactly one, because that's what defines our year. Our year, or we might call it a tropical or sidereal year, there are many types of years, but most of the time we just define it as Earth orbiting a sun, which is pretty simple really, and that's what makes our year, so it's just one, very nice and simple. Second one, how do our bodies work? The thing is, our bodies are all made of our organs and of course our skin, our muscles, our bones, our blood. Gross. And of course, they're all made of cells, little bits of tissue, basically flesh essentially, but made little cells that each have different parts and they perform functions. It's really actually amazing how they all come together to make this giant, elaborate network of things. Of course, those cells are made of all these molecules, which are made of atoms and so on. But yeah, our bodies work just a complex system of different systems like circulatory, respiratory, so we can do things like breathe and pumps nutrients around our body, and it's really amazing. They just create this giant ballet of incredible tasks. Third of all, how hot is lava? Lava, or magma when it's underground, is simply molten rock and just melted, just everything. It's really hot, it's like almost like liquid fire, and it's often comes from volcanoes, and it's extremely hot. It's from between 800 and 1,300 degrees Celsius, or in excess of 1,000 to 1,500 Kelvin. And fourth of all, why does the moon change? You might see the moon go through phases, going a full moon, gibbous moon, half moon, crescent, and then new moon, which is when you can barely see, just a darkened silhouette. The moon is always there, even when you can't see it or can't see most of it. But the thing is, this is because the only reason you can see it is because the moon is very good at reflecting the sun's light. It doesn't, when you see all the moonlight thing, it really doesn't actually have its own light. It's just reflecting the sun's light, and that's why we can see it. But of course, it's at a different angle. Like the far side and the near side will always rotate around about a month, which is why you often hear that the moon is something to do with a month. That's how long it takes to spin around and also go around the Earth. Which is why we see it first go waning where it gets smaller, and then waxing where it gets larger again, and you just keep repeating. Although the moon months don't really fit into a sun year, because a moon month is about a bit shorter, about 28 days. Fifth of all, how big is Earth? I've previously answered the moon and the sun, but now it's time to answer the Earth. The Earth is a little bit larger than Venus, and it has about a diameter of just over 13,000 miles, which is quite a lot. It's about, I'd say it's about 20,000 kilometres or 20 million metres, going from one end to the other end, the north to the south poles. And that makes it the biggest of the small inner rocky planets you might have heard of: Mercury, Venus, Earth and Mars. Earth is slightly the biggest, and it has a circumference, that means going around it completely, of about, I think, 25,000 miles or 40,000 kilometres or 40 million metres, which is a very big amount. And anyway, the next question is, question number 6, why do we need oxygen? We need oxygen so it can help our respiratory and circulatory systems, because basically how it works is when blood gets pumped around, at one point the heart plus under the lungs, it goes to the lungs, which supply oxygen. That oxygenated blood goes around helping our body, which is good, until then it goes back to the heart where it's used up and our heart's able to pump it again, and it just repeats. Without oxygen, our blood would just be all blue, and we would just suffocate, because we need to breathe. We need oxygen to breathe. We need to fill our lungs to provide us with the glucose from the reaction. Number 7, what is noise, or as we call it, sound? Thing is, everything emits waves, electromagnetic waves, which are very complex, but they're basically electricity and magnetism, just really weird, like waves, the way radio works. Some things emit like pressure waves. You've probably seen ripples in water as waves, but there's also one type that everything does. Every reaction, every physical interaction causes sound. Probably things like our vocal cords or our mouth moving, or two things banging together to make an instrument, or so on. And the thing is, our sound waves can be more intense, which is louder, or even higher pitched in certain ways. The way a sound wave operates really defines what sound we hear. But how do we hear? Well, essentially, they hit our eardrum, and our eardrum vibrates really loudly. It's like a drum, but it's even more sensitive. And again, how it hits the drum defines how we hear sound. And when it hits the eardrum, literally it sends signals to your brain, and that's it. Your brain literally just kind of perceives that. How we actually see, I've always thought about how we actually, I know how we see and hear, but how do we actually? Consciousness is so weird. It's weird how I can actually see in this world of just atoms moving around. And that's the thing. And because it literally is, just your brain just then makes the noise as you receiving that signal, which is why certain billionaire inventors are inventing microchips that can literally stream the signals directly into your brain, cut out the eardrum middleman, so to speak. And then question 8 is, how does paper come from trees? Well, you might have heard of things like logging. It's not very nice, but it is how we get our paper, although actually logging industries do actually replant trees. But we basically after you chop down the tree, it gets further chopped down, or as we like to say, quite literally, smashed into a pulp. This wood pulp is then stretched and filled with things like water and glue fibres to make paper. That's why they tell you to not waste paper to save the trees. Question 9, how did life start? Well, approximately 3,800,000,000 years ago, which is a long time. It's very old. Basically, it's pretty much chance. We just saw that apparently, scientists have discovered using fossil records that literally a few billion years ago there was actually water, and water is something that's really rare because there's only a tiny habitable zone of the solar system, which we are luckily in, where water is at the right temperature to be a liquid. And people saying that it might have been water on Mars, but it's frozen now. And then this water, all it took was one thing, and boom, life. It was hard to explain, but it was just a single cell, literally tiny. It was a prokaryote, as you say. It was literally practically nothing. It was smaller than bacteria, tiny, but it could split and slowly evolved. And okay, you had slightly big cells and slightly small cells, long cells, thin cells, but it was nothing. But then one cell just happened to get eaten by another cell, and it didn't die. It actually, basically they made an agreement, kind of a silent agreement. One of them would provide the bigger one would provide shelter and accommodation and nutrients, while the small one would help produce nutrients for the big one. It's what we now call the mitochondria, or the powerhouse of the cell. And that's when beings started making their own energy, and that's when life really started. And then it just went from there. Then we got fish, then we got crabs and other things, and then, by the way, things are often evolving into crabs, just thought I'd tell you that. Then we got fish and reptiles, and then we started to go on land when there was food there, and they invented better eggs. So yeah, and then land, and then it just kind of evolved from there. And then we had dinosaurs and birds, and now here we are. Question 10, how many days in a year, or 6 years? Someone also asked 6 years. Well, it's hard to really give a precise figure. Some say 365, but leap years have 366. The true answer is around 365 and a quarter, which is why we have that extra day every 4 years. It's a bit less than that, so that's why we also cut out every 3 and 400 leap years. But that's a topic for another day, perhaps. But anyway, yeah, and thus in 6 years, if you multiply them, that means that there's 2,071 and a half days in 6 years, which is thrilling stuff. And that means that, well, question 11 is, what is space? It's just mostly an empty, almost vacuum, just really cold. Empty. Oh, but there's big giant stars and everything. But question 12 is, how did the stars begin? Well, about 12 or so billion years ago, just about 13 billion years ago, about almost a billion after the universe started. Obviously everything was hot and dense, but things actually managed to start forming out of the chaos, and that just grew to go into stars. Now stars, how they work is they provide their own energy by basically being so hot in the centre that they fuse hydrogen into helium, creating giant amounts of energy, but we'll actually get onto that later. And they managed to barely stay like that, and they stabilised, and that's why we have stars now. Our sun is a star, by the way. Question 13, moving away from the thing about space, is how long does it take to build a skyscraper? It depends on things like the height, what materials you need, the width, just the size. But nowadays, our things have gotten so good that it used to take things like 2 years, but nowadays we have things like, we can build like a floor a day, depending on how small the skyscraper is. Question 14, a little bit later on, how did Earth begin? Well, the sun began like other stars, but then, about 5 billion years ago, we'll also get onto that later on, but the Earth began about 4.8 billion years ago. The rocks just collide together, and then the gravity just kind of skadoosh Earth. And then the moon formed 200 more million years later, when it collided into Earth, shattered into rings, and then formed back together into the moon. And then it's pretty much a similar thing with the other planets, it's just gravity and of course the sun's pull. Question 15, why are stars important and why do we need them? Stars are important, especially our sun, because the sun is very important because it literally provides the heat we need to live, the gravity we need for our Earth to remain in a stable orbit, etc. But other stars are still useful for things like navigation and for just other things like making the sky look good, as long as there's no light pollution. But they're pretty much good for navigation and learning better about how different stars can work. Alright, we're entering the final 5 questions. Let's go. Quick fire round. 16. How many times does the Earth spin around or rotate every day? 1. Just like the Earth going around the sun in a year, that's what defines our day. It takes about 24 hours. Question 17. How many years will it take for the sun to die? The sun's about halfway through its life. After another 5 billion years, it'll expanded so much, it'll become a red giant and just dissipate. It's just pretty small to medium star, so it'll just, tiny white dwarf left behind. Bigger stars collapse into and have supernovas, collapse things like neutron stars and black holes, but whatever. I've talked about black holes enough. Question 18, why are stars so bright? Because of the fusion energy in the cores, the photons, aka light particles that go into our eyes, it takes a while for them to escape the maze of the plasma of the sun, but when they do, there's a bunch of them just coming out in all directions. Just so much energy, it's just so bright. That's why our sun is so bright. The photons react with the atmosphere, make it such a bright blue instead of just a black that you see at night time. Question 19, can chickens fly? No, they can't take off, but they can, if dropped from a high place, they can flap the wings to at least glide. They can fly over about a few feet for a few seconds, but they're really not good at flying. Other birds are better at flying. They don't fly, they just fall with style. And finally, question 20, how did the first people exist? Quite relevant. Well, it's what I said about the evolution. Dinosaurs, and then they just got extinct, and then a few small mammals survived, and they just evolved. And then you might have heard that we've come from apes, but technically we share a common ancestor with apes. You probably might be wondering why there's some still today. Those ones just got unlucky and didn't get the evolutions. Yeah, we still share a common ancestor with the apes, which then evolved slowly into beings that could walk on 2 legs and use tools, which is crazy considering literally no other animal could ever do anything like that ever. It's really amazing how it's literally a 1 in a million chance that this happened. They just slowly evolved into humans, and then we actually started making caves, and then we built civilizations. And then history happened, and now we're here with the modern day, which is literally just crazy that we even exist. And I want to say it's time to just be happy that we exist in this hard time. The certain virus that I cannot name. It's been hard, but to existence. Also, thank you to Apple Class, really thank you. And you might want to check out my other videos, which are pretty good. I've actually done a lot of videos, and I think this channel's growing quite well after this hiatus. So thank you very much. Subscribe, please. Bye.